previously we learned how a single neuron worked, and in this section we'll be talking about neural networks. Okay, so just to review, when working with a single neuron, what we saw was essentially that we had a hypothesis function, which meant that we were passing data first into our linear function, and then that output is then going to be passed to our sigmoid function, right? So remember, this returns any value from negative infinity to positive infinity, and we're effectively just using the dot product to do this. And then finally, we had that activation function, which squishes down our results between 0 and 1, where the closer our output is to 0, the more confident we are in a negative prediction. The closer the output is to 1, the more confident we are in a positive prediction. So that's like our hypothesis function. Right? And then the next thing was our training procedure. And the main thing about our training procedure is that we would try, we were going to basically get a data set, get our training data, and we also had the answers. We had, these graduate students labeled for us. This was cancerous, this was not. And we were then going to try out different parameters. Here we did this with a single parameter value, W1, right, a weight. And we said, okay, if the weight is -2, well, here, this is what the sum of the squared errors was. This was our cost. And we then went to update our weight, right? And the way that we did that was with gradient descent, where we moved in proportion to the slope of the cost curve, right? So our first weight we chose randomly, and the second weight we are updating by multiplying the slope of the cost curve by negative times by the learning rate. Okay? And we just repeatedly do that until we approach the minimum of our cost curve. Now that works fine for something like predicting cancer. Or in other words, I should put it, for our structured data, for these like rows and columns. But when want to move on to like images, just using a single parameter and just using a single neuron, well, that's going to fall short. So if we want to, say, be able to take an image and identify that this is the number 5 and this is the number 0 and 4 and etc., how do we do something like that? And the answer is more neurons, right? Like just add more power. So what does that mean? We can see this is a diagram of a neural network, and there's a couple things to take away from this. So each of these blue dots right here represents a different neuron, okay? And you can see that these neurons are effectively like connected, just like we kind of saw up here. The other thing that you can see is that these neurons are stacked in layers. So this is, one layer, and then there's a next layer, and there's a next layer. And information from this layer, right, the outputs of these neurons are then being passed along to be the inputs of these neurons, and then so on and so on until we finally get a prediction like, I think this image is the number 1. So why do we use, these layers? Well, the idea is that maybe the first layer deals with kind of something very concrete, like, all right, are these pixels black or white? And then the second layer maybe deals with something a little bit more abstract. Let's move this down, sorry. It deals with something maybe a bit more abstract, like say, is this now like curved or a straight line? And then maybe this layer deals with something more abstract than that, like, all right, do we have like 2 edges together? Or do we have something like a circular region, right? So the point is that when we're doing this information flow, we can go from making these very concrete, our neurons can go from making these very concrete determinations, like, is this region lit up or not, to something more and more abstract until it gets to the most abstract, which is this number 5 or not, right? So that's why our neural network operates in layers, and we're going to see this throughout the lessons. But for now, what you'll also see is that in Pytorch, this should look kind of familiar to you, right? We have our nn.sequential. So this is us creating a neural network with more layers and with more neurons. But it looks kind of similar to what we saw before, right? We start with our linear layer, then we have our activation function, the sigmoid function, and then we're simply adding in another layer. And then here's kind of a special kind of activation function that we'll talk about. And, so it's just really is like more layers. And the other thing you can see is that if we select one of these layers, it is more complicated. So let's just look at the weight. Weight or weights? I forget. I guess it's weight. Yeah. You see all this? These are a lot more weights than we dealt with previously. And there's this ... means that there's even more. Okay? So I'm trying to look at the shape. Yeah, so there's 64 times by 784 weights. So just in that first layer, we have 50,000 weights. Sounds like a lot. Okay, so we're gonna see, how does something like this even work? How does the math work? How does the code work? And to really understand what's going on with a neural network and some of the issues that can occur down the line with neural networks, it is important to, understand some of the math behind it. And like I said before, understanding that math, that will really cover a lot of the math that you need in machine learning in general. We're just going to take it step by step again. All right, so with that, now that we know, we're about to be using more neurons to try to take these more complicated problems like being able to do image recognition. Let's get to it. Okay? Awesome. See you guys there.